So today you are working on the remote lab called Lab Matter and Conservation of Mass. So part one, simply go back to your notes, look at how we define mass, and you have a series of terms, and you need to determine, like when you look at the word toothpaste, now think about what you know about toothpaste. Does toothpaste represent a form of matter, a type of matter? You know it's definitely not matter, or you're not sure. So you need to take this word toothpaste and then you need to annotate it in the column in which you think. As you work through all of these terms, okay, then you need to do your CRE question format. So first, keep your claim simple. Make your claim. What do all the samples of matter have in common? What is the evidence that you looked at from your prior knowledge? And then your reasoning, something from the theory in the notes. Keep it simple. And now we're moving on to part two. So now part two, I've provided you some background on your document, reminding you about the law of conservation of mass, which is also in your notes, and we're going to collect some data. So trial one, we're going to work with salt and water, and so I have a paper cup that's containing salt, a paper cup containing water, I have a stirring rod, and I have a digital balance. So as I am working with the materials, you need to pay attention and do a brief set of procedures, a summary of how I collected the data. So significant data, since we're talking about the law of conservation of mass, is measuring the mass, but then it's also important to look at other things that maybe happen during the lab and record additional observations. So let's start collecting the data. So I have them on, here's my digital balance. I have a piece of paper towel on the pan. So for the filming, it creates less of a glare. So I'm going to zero out the mass of the paper towel. Okay, and here is my paper cup containing regular table salt. And here is my cup with water in it. So now I can record the total mass of the salt and water before I mix them together. Now, to mix them together, it's not a good idea to do this on the balance, so I'm going to remove them. Okay, and now I'm going to carefully pour the water into the cup with the salt. And here is a stirring rod, and now I am just going to use it to blend the salt and water as uniformly as possible. And before I take the stirring rod out and lay it on the counter, okay, and now that I have blended my two starting materials together, now I need to measure the mass after the change. And notice what I do. Go ahead and record that. So now you need to look at the data and take into consideration what the law states and make your claim. Did mixing the salt and water follow the law of conservation? Make your claim. Your claim cannot be a simple yes or no. It needs to be a short statement. Use evidence. Evidence is what we record or observe in the lab, and then reasoning. Now, we're going to talk about the second trial, so the second trial of part two, we're going to use baking soda, which I have in this cup, and vinegar, which I have in a second paper cup. So I need to measure the total mass before I allow the baking soda and vinegar to mix. So let's collect some data here. Okay, mass before. Now, I never mix them together while they're sitting on the balance, so I'm going to take it off. So there is the baking soda, and now I am adding in the vinegar. Okay, and now I need to measure my total mass after. And so now I can measure my total mass after. Now, one of the things that we have to talk about are when we record mass values. So let's take a look on a sheet of paper. I'm just going to flip this sheet of paper over. Now, if you have worked with these digital balances in the past, you will notice that sometimes that this last digit will start to fluctuate. So you see it's right now it's going between a 4 or it says like a 6 and a 7, and once it shot up to an 8, that digit in the hundred spot. Okay? The digital balance is estimating. So let's take a look. So if your mass is 5.46 grams and somebody else's digital balance, same piece of equipment, or they put it on, says 47.6. This is the position where our digital balance keeps flickering. And so this is the place of estimation. So if I estimate a 6 and you estimate a 7, is that reasonable? And yes, it is. So with this, these two masses, because they only differ in that place of estimation, the place where the digital balance keeps flickering back and forth, they represent the same mass because they only differ in the place of estimation. Versus if you measure it as 5.46 grams and then your partner puts it on there and they measure it as 5.56 grams, you will see now that they are differing, not in the place of estimation where the balance flickers, but in a place that should definitely be read. So the 6 is still the place of estimation, but the tenths is not. So these are different masses. So those are some of the things you got to take into consideration when you're looking at measured values. Measured values, it's okay if they differ in the place of estimation, but they must be the same in all of the other places recorded.